Hello, General Biology, and welcome to Chapter 5. You're going to see that this format looks just a little bit different than what we've done in the past. That's because we're only going to highlight some things within Chapter 5. So we're going to take a look at Section 5.1, and Section 5.1 talks about how populations grow. And we're actually going to see that there's 4 ways that we can study populations. And the first way is through geographic range. And the geographic range just talks about or defines the area that is inhabited by a population. So you can see here, and let me see if I can get my pointer to go. My pointer's not working. Here we go. You can see here that this is the map of the United States, and this shows you the geographic range. The darker areas are where it's more densely populated, and the lighter areas are where there's the least density in the population across the United States. And when we think about in terms of species, as you can imagine, the range can vary depending on the specific species. So if we're thinking about bacteria, which are really, really tiny, we might be thinking about, maybe just a small little sliver of cheese, or as it says here, a piece of bread, where if we're talking about a fish population that might live in a lake, the lake would be better, obviously, bigger, than the bread would be. And if we're looking at human population, we can go across the globe, so that's even bigger. So I guess what this is exampling for you is that geographic range, no matter what species, is really going to be basically the same thing, and that's the area that is inhabited by a particular population. Then we look at density and distribution, and that's what this map is. This map is actually a density and distribution map, and it shows population density. There's more people that live per square mile in the darker areas, as I had stated earlier, and that's how we calculate. We look at the number of individuals per whatever the unit area is. So if we were looking at that bacteria, and let's say our piece of bread was 1 inch by 1 inch, then we're going to calculate how many individuals are living within that unit area, that inch. Where if we're looking at a lake where fish live, and maybe that lake is 11 miles long, then that is going to be our unit area, 11 miles, rather than that inch by inch. So here's an example. If there were 60 ducks that live on a pond that is 3 acres in size, and we wanted to know how many ducks live per acre, we're just going to take the size of the unit area on top, and we're going to divide it by the number of individuals, 60. So 3 divided by 60 is going to give you 20 ducks per acre. And that's how we figure out population density maps. So if we take a look here, this is 591 people per square mile. It's actually 591,000 people per square mile in the area. So that's a lot of people that we have living along the East Coast. And you can see it's more densely populated in this area. So when we look at the distribution, we look at how they are spaced out across whatever our range happens to be, whatever our size happens to be. How are they spaced out on that 1 inch piece of bread? How are they spaced out across that 11-mile lake? How are they spaced out across the 50 United States? Okay, so geographic range and density and distribution make up two of the ways we look at how populations grow. Another way to look at how populations grow is by the growth rate. And the growth rate is going to actually determine the size of the population. And that depends on the number of births and the number of deaths, as well as immigration and emigration. So we look to see, do we have more births than we have deaths? If we do, then that's going to represent exponential growth, that we're growing at a steady rate. If we have an equal number of births and an equal number of deaths, then that's going to mean that we're kind of stable. We're not growing, we're not decreasing. If there are more deaths than there are births, then that's going to show a declining population. And then when we factor in those people that are immigrating in and those people that are emigrating out, that too is going to give us part of the growth rate. Immigration means people that are moving into a country. In recent years, we've had a lot of Mexicans and a lot of Cubans immigrating into the United States. Emigration, they are emigrating Mexico, they are emigrating Cuba. So that is having an effect on the population growth within those areas. And the fourth way to look at the growth rate, how populations grow, is to look at the age structure. And you're going to see these graphs again, and you're going to see them on the midterm exam, and you're going to see them on your test. These are called age structure graphs, and what they do is they tell you the number and the ages of males versus females. So this side of the graph for this particular chart is for males, and this side is for females. And this represents Guatemala and Nigeria and Saudi Arabia. And as we go to the bottom levels, this is in these three rows, this is children ages 0 to 14. And then in this next area here, this is ages 15 to 44. This next area is ages 45 to 85. So what we can do is, as we're looking at this, we're going to see that there is a very high birth rate in this country. There's going to be a lot of children born in this country, and they survive well into their 50s and 60s, but then we see a sharp decline where there's not many living at the age of 85. So high birth rates, and they don't live very long. When I look at this, I say, ooh, this is an industrialized country, because they need to have more children in order to help with the parents bringing money in and farming. It also suggests to me that children aren't going to live that long. I mean, they look like they do relatively well, but you're thinking in these countries, especially when you look at the girls, probably at the age of 14, you're starting to have children. You're probably on your second or third child, and look at the sharp decline that you have in females. And that's because they're lost in childbirth, because they have midwives and not hospitals, and they don't have the proper medical care. And most of the girls, right after they have the children, they're going to go back and they're going to work on the fields, and they're going to be taking care of the younger children and helping to bring any money in or food in for their family. They live in carcinogenic huts as well, so there's a lot of risk factors that happen. Here is a age structure population profile that shows zero growth, and this represents Spain and Austria and Greece. And what we see is it looks pretty stable, not much increases, and we see people living well above their 80s into their 90s. And in this case, the females are actually outliving the men. And what we know in countries like this is the men typically do heavy labor in some of these countries, and the women do not do as much heavy labor. So we see zero growth. Here is another one that is negative growth, where we see low birth rates. All right, sorry for that interruption. Somebody was at the door, and Nico is our doorbell. He let us know. Okay, so this was negative growth. We see lower birth rates in this particular time of frame. They were higher at one point in time, but they are moving up, and we see that they are moving up with this, because earlier the population was bigger, but now birth rates have slowed down, so this would be a negative growth curve. So I can look at these and I can tell you whether a country is industrialized, and that's one of the things that we're going to talk about. Has it reached the top of its technologies? Is it economically stable? And I can give you an idea which ones are. And I would say that this is not an economically stable country, that this is a relatively economically stable country. We're going to talk about in industrialized countries that having a lot of children is not economically wise. So the richer the country is, the less children people tend to have. And this shows some kind of negative impact that is happening within that particular population for some reason. All right. So when we look at population growth, we look at population growth in two ways. Is it growing exponentially? And that's at a steady rate where it's increasing. There are no limiting factors that are getting in the way of the growth. The conditions are ideal, the resources are unlimited, and we're going to see that the population is going to grow at a steady rate. And it's represented by what we call a J-shaped curve. So here is exponential growth that represents the J-shaped curve. It's the number of elephants, and it's in millions, versus the growth of the population and the time in years. So here we're seeing that, early on, we're seeing low amounts of elephants, but in 500 years, we're seeing a steady incline in the growth of this elephant model that they're following here. This is not true right now of elephants because they're being hunted to extinction for their ivory tusks, but this gives you just an idea of what it would look like. A logistic growth curve, on the other hand, shows what happens when you do not have limited resources, and that they are not unlimited, and that it reaches what we've learned already about carrying capacity. So what we do is we see an exponential growth. It's going to increase. There's our J-shaped curve, but then it slows, and it's not really stable. It kind of goes up and down as it levels off. It kind of fluctuates a little bit, but still maintains a pretty steady level line. And this is more of an S-shaped curve. So we see that in phase 1, the population is going to grow really rapidly. In phase 2, we're going to see that growth slow, and then we're going to see that growth of the population stop, and it stabilizes. This is what is meant by carrying capacity. We've reached that carrying capacity. And that's what we saw when we did that deer activity. When we had equal amounts of the environment and the deer were able to increase in number. But once we had the limiting factors where we lessened the amount of environmental supplies, we didn't have as many. We're going to come back to this. I'm running out of time.